Saxon Algebra 1, Lesson 8. We're going to talk about area today. Please forgive that big crease across my paper, which looks bad enough in real life, but on camera, the shadow catches it. And it looks like a mountain range is passing across my paper. Sorry. So sorry. Okay, area. Up until now in our review, of course, we've talked about area in the past, but so far this year, we have talked about perimeter, which is measuring around the outside of a polygon, a shape with straight sides. And we've talked about circumference, which is measuring around the outside of a circle-y shape, right? Different formulas for that. Here we just added up. Here we have a fun little formula that is circumference equals pi times the radius times 2. These two measures measure length. Which is to say, they measure one dimension. Okay, we're just measuring around the outside. We're not measuring what's in the middle. We're just measuring around the outside. And sometimes it's helpful to think you could take like a piece of string, right? And lay it around the outside and then cut it. And then you could pick up that string and it would just be a long skinny string and you could measure it. And that would give you the length of that. That's how these two measures work. Today, we're shifting gears to talk about area, which is to say, now we want to measure the inside of an object. We will measure rectangles and squares. We can measure the area of circles, and we can also measure the area of triangles. We're going to cover all of that in this lesson. It's kind of a long lesson, you guys. If you need to take a break in the middle, please do so. All right? When we measure area, we're measuring two dimensions. And the easiest way to see that is when we are measuring the area of a rectangle. It's length times width, right? And to help you get the picture of that, with a rectangle, we usually call the longer side the length, and you'll notice that I always use kind of like a cursive L, so it doesn't look like a 1. If I use just a lowercase l, it would look like a 1, and that's confusing. So the longer side is usually the length, the shorter side is usually the width, but honestly it doesn't matter which you call which, as long as you just take one of each side, okay? When we have a perfect square, we can use a slightly different formula if we want. We don't have to. It's called the side squared, because if you think of a square, every side is the same, right? So we just call each measure the side. And we multiply the side times the side. Since they're the same, we can abbreviate it as side squared. So, but this will still work, right? If you just realize, oh, I have a square, so even though I'm calling them different things, it's gonna be the same number all the way around. This one works too. All right, let's take a look at a couple problems in which we can apply this lovely knowledge of ours, which I know this is all review, but just pretend it's new and different. All right, these pictures, it says find the area of this figure. All angles are right angles. Dimensions are in centimeters. I like to write the dimension here and circle it. I'm not gonna need that until the very end. I'll just put that label on my answer. I like to recommend that you draw the picture yourself in your homework. It helps you notice details, and it gives your brain a chance to work in a slightly different gear. Math and art are not opposites. They're like this. They're dovetailed. They complement each other. And by taking a minute to focus on kind of the artistic side of this problem, it allows our brain to stay in gear. It doesn't distract us, but it helps us notice different things, and it gives us a little moment of rest and refreshment in our brain so that we're better prepared to tackle the problem. I really, really recommend it. I've also run into parents who have told their students, why are you wasting your time copying the pictures? Don't do that, just focus on the work. And I have to gently remind the parents that this is part of the work. This is the problem, this is doing the homework, this is a helpful process, so please do it. Okay, so what we have here is a nifty little diagram that is not a simple rectangle, is it? It's two rectangles put together. We can look at it two ways. So I'm going to draw two mini versions of it over here. Pretend they're all exactly the same. What you can see is that we're going to need to divide this original shape into two rectangles. There are two ways we can do that. We can mentally divide the two like that and say rectangle A and rectangle B, or we can do it this way and say rectangle A and rectangle B. It doesn't matter. Either way will work. Either way is just fine. It's simply a question of what your brain notices first and what feels like a good way to do it to you. Since I chose this one first, I'll choose to do this way. Okay, and what I like to do sometimes is just label these. This is going to be rectangle A and this is going to be rectangle B. All right, that gives me a way to keep my calculations all in order. So here's what I'm going to do. I'm going to say, let's find the area of rectangle A. And I'm just going to put that inside of a box to remind me that that's a rectangle shape. The formula to find the area of a rectangle is length times width. So I write the formula down. Now I need to figure out what's the length and the width of A. Well, the long side of A is 5, isn't it? And the short side of A is 2. So I multiply 5 times 2 for a total area just of A equal to 10. All of that. Now we'll do the area of rectangle B. Same formula. Later this will get more complicated, but I always want to write my formula down. Now I have to look at B. And here's where it gets tricky. I want to say that the length of rectangle B is 6, but that's not right, is it? Because that includes this section here that I've already counted in A. So I have to look more carefully, and I realize 4 is the long side of rectangle B because it only includes that space. So length is 4, and then the width is 2, right? 4 times 2 equals 8, and then we add them up and we get 18 centimeters. An area is always a square, so we put the exponent on there to indicate square. 18 centimeters square is our answer, and that's correct. Yay. Okay, I hope your brain is warming up and you're like, oh yeah, I remember these. Let's do one more problem with rectangles and then we'll move into triangles. Example 8.2. Drawing the picture. Okay, this is an interesting picture. Looks very different from the first one. We've got a rectangle in a rectangle The big rectangle is shaded. I'm going to shade that in a minute, but first I'm going to put in these numbers. They're kind of hiding in the shadows. You have to look carefully. 6 is meant to be this dimension, and then 2 is meant to be this dimension. You really have to look carefully to see those numbers hiding, because the rest of this is shaded. I'm circling the numbers so that it's easier to see them once I shade the appropriate regions of my rectangle. Okay? Now, these shaded problems, whenever you have a problem with what's affectionately known as a shaded region, shaded regions mean subtraction. Take that to the bank. That's a really important piece of information. These shaded region problems throw a lot of students off, and so you often see them in placement tests, standardized tests, etc. The key to understanding these is to imagine the outside shape, this rectangle, as a piece of toast. Have you ever done the thing? I'm sure you have. Everyone does it. You fold your toast in half and then you bite on the fold, and then when you open it back up, there's a hole in your toast, right? So imagine that this is your piece of toast and you have folded it probably along this axis, although you could have done it that way. But let's just say this way. You folded it and you took a bite out of it, and there's the little square. That weird little analogy will help you remember how to solve these, because what you're going to do is first measure the toast and then measure the bite. Does that make sense? Weirdly, I hope you're going, yeah, I sort of get it. So we're going to find the area of the toast, and then we're going to subtract the area of the bite, right? And that is the subtraction that I'm talking about, that these shaded region problems always involve. So the area of the toast, we look at our numbers to see what we can find. Oh, there's the length and there's the width. So again, I always write my formula down, because later we're going to be doing problems that involve multiple formulas, so we'll want to be straight on that. The length is 10. The width is 8. So that means our overall toast is 80 units. And let me look. See, I didn't write down. Dimensions are in meters. That means this is a very large piece of toast, because most dads are about 2 meters tall, so that means this is like 5 dads long. So that's a big piece of toast. Now we want to measure the area of the bite. It's a rectangle, so again our formula is length times width. This time, however, it's 6 times 2, which is 12, and remember we're subtracting that. So when we do, we get 68 meters squared, again because we're finding areas. That is the area of the shaded region. It's the whole toast minus the bite. 68 meters squared, and that is the right answer, yes. Okay? Before I turn away from this page, I want to point out one more thing. Do you see how I'm deliberately creating like a little chart here with columns? I write the area that the part of the picture that I'm calculating. I write the formula. I show the way I'm calculating that, and then I show the answer. Having this kind of a very intentional system is going to help you keep your thoughts organized. Later, we're going to have more complicated shapes, and we're going to be using lots of different formulas. You probably remember this from last year. It's very important that you keep your work organized neatly so that you don't lose your mind in the middle of all these details. So pay attention. I mean, this is true for every lesson, but pay attention to the way I format my work, because I do that very intentionally after years of practice. You guys know I've been teaching algebra for 21 years now. And so I have tried lots of different ways to organize my work, and I really recommend that you benefit from my experience. And I will follow that up by saying, I used to get really annoyed when my teacher said I had to lay things out a certain way, because I thought, well, I don't necessarily want to do it your way. I want to see if I can come up with a better way. And I'm open to that, as now, you know, I'm standing in the teacher position. I get that. Go ahead and try. Just make sure that you're being very intentional to try to make your work really neat and well organized. And keep in mind that I've tried a lot of different ways before I settled on this. So I'm just trying to help you out, but I know that sometimes we don't like to be helped, do we? Sometimes we like to figure stuff out for ourselves. So, area of triangles. Okay, let me just look at something here. The first thing we want to do is find a basic formula, right? The tricky thing about triangles is that they come in different shapes. And I know we've already reviewed this, but this is an acute triangle, this is an obtuse triangle, and this is a right triangle. And they're all slightly, the formula is the same, but the way we deal with them is a little bit different. The basic formula for the area of a triangle is base times height divided by 2. That is true for all of these. All right, the base is the easy part. It's always where how the triangle is sitting, right? So that's the base in all 3 of these triangles. Height is the tricky one, because the height, how and where we measure the height, is slightly different depending on which of the 3 types of triangle we have. But a spider can help us. If you will send a spider to the top of your triangle, I know these are 6-legged spiders. I know spiders really have 8 legs, but for some reason that just looks wrong. I send a spider in to help me find the height of my triangles, because if a spider will drop a web straight down, they go to the high point of the triangle and they drop a web straight down, that will show me the height of my triangle. This, on a right triangle, the height is equal to this side. So I'm showing it as slightly different, but it's not. Notice that I'm putting in this little right angle marker. That is to show that the spider's web goes straight down, which is exactly how we measure the height. It's straight down and it creates a right angle with the ground. So when we have this style of triangle, notice the height goes down the middle. When we have this kind of triangle, notice the height goes outside of the triangle. That's kind of weird, isn't it? But don't let it freak you out. And also notice that there's this little outside section. That is not part of the base. The base is just the green part. This pink part is just the ground under the triangle. Right triangles are kind of fun because the height is equal to one of the sides, isn't it? It's not true in these other ones. The sides are completely different measures. All right, so height is the tricky part when we're finding the area of triangles, because it varies depending on the type of triangle that you have. I just want to write this though. The area of a triangle equals, I'm going to write it out this time. Okay, that's what the B and the H stand for. I want to make sure you have that in front of you. Okay, so there is all kinds of lovely information about triangles, how we find their area, and what that can actually look like, right? So we can say the area of a triangle equals base times height divided by 2, which is the formula I used up here. Sometimes it's helpful to say it like this, though. Sometimes we say the area of the triangle is equal to 1/2 base times height. Because you know how to multiply fractions, you realize, oh, that's exactly the same thing. But sometimes it's easier to think of it one way or the other way. All right, so I want to show both of those to you. Make sure you write all of these formulas that we've discussed so far today in your formula page, on your formula page. All right, let's do a few problems. My pages are still crinkled. Example 8.3. Find the area of these triangles. Dimensions are in inches. Okay, and this is an ABC kind of affair. Here's triangle A. Three, 4. Now I will say this. If the problem's super easy and you look at it in the book and go, oh, I automatically know, well, 3 is the height and 4 is the base, I'm just going to write the formula up here. So I can see it for all these problems. I'm not going to keep writing it. If you can just automatically go, oh, base times height divided by 2, it's 3 times 4 divided by 2 equals, we can reduce there, 6 inches squared. There's my answer. You don't have to copy the triangle, but a lot of times it does help. All right, let's try B. Oh, do you see what John's doing here? He's giving us practice in the different types of triangles. He shows us that, he shows us that, he shows us this, and he shows us this. Same thing, you probably don't even have to draw this one. Base 4 times height 3 divided by 2. Notice here I wrote the height times the base. I kind of reversed those two, but remember we're multiplying, so order doesn't matter. It's okay to put them in the opposite order. Here I put them in the order just like the formula though. And again, that cancels. And we get, oh look, the same answer. Interesting, right? C, you'll never guess what shaped triangle this is. Obtusey boy. And this one, remember that the base is only the solid part. It doesn't include that. But we're told that that is 3. Oh, so look again, base 4 times height 3 divided by 2, those reduce. So even though these triangles have very different shapes, their area is the same because their base and their height are the same. Oh, good to know, right? Okay, let's try the next one. John's trying to be tricky here. And this time he draws a triangle that's like this. What in the world? 6, 8, and 10. Okay, so I just want to write this up here. Area of a triangle equals base times height divided by 2. When you're working problems in your homework and you need to use the same formula multiple times, like these problems that we're doing, I want to make sure that that formula is written on each page. So if you're doing multiple problems on the same page, you don't have to keep writing the formula as long as it's already been written on that page so that your eyes can land on it quickly. When you turn the page and you need it again, rewrite it again so that it's right in front of your eyeballs. Okay, dimensions are in feet. Now, this one's a little tricky because the triangle isn't oriented the way we're used to it being oriented, and it seems kind of backwards and confusing. Here's the interesting thing. We can use the triangle in any one of these orientations. We can make any one of these sides the base and any one of these sides the height. So if we wanted, we could call this the base, but then we would have to spin the spider up here and we would have to find the height like that, wouldn't we? We don't have that information. And right now we don't have any tools to find that information. Later you're gonna learn how to do that. So what makes more sense is to reorient the triangle so that there is a clear base. Now there are two ways to do that. We could do it like that. Let me see, let me spin that. That would make this the 8 and this the 6 and this the 10, right? We're turning it this way, right? Or we could put the 8 down here. We could turn it this way. The 8 would be on the bottom, the 6 would be here, and this would be the 10. Either way you see it, okay, we want to spin the triangle one way or the other way. My brain sort of automatically goes to that, but this will work too because look, we're doing base times height divided by 2. The base is 6, the height is 8. We divide it by 2, but look, if we drew it this way, well here we'd have the base was 8 and the height was 6. So it doesn't matter which way your brain spins the triangle. Our spider is still going to go up to the same point and still drop the web. This is the one where it's next to that side. And then we can reduce and we get 24 feet squared as our answer. All right? So don't let a floaty triangle freak you out. Just spin it to the way you want it to look and redraw it and you'll be fine. Okay, and there's no one way you could draw that either way you wanted. Okay, example 8.5. Now let's up our game a little bit here. Now we're going to have a figure that is combining shapes. And this is where that chart way of organizing our information is going to be helpful. Find the area of this figure. Corners that look square are square. Dimensions are in yards. Okay, there's our unit. Now, here comes our picture. Looks like the way a little kid would draw a truck. 6, 4, 10. Now, how in the heck are we going to find the area of that? Here's what I want your brain to learn how to do. I mean, you already know, so we're going to divide this into two shapes. That line is straight. Here we have a rectangle. I'm going to call that A. Here we have a triangle. I'm going to call that B. Now, we don't know yet if we have all the information we need, but let's just start with what we've got. For A, we're trying to find the area of a rectangle, right? That's a rectangle. The formula for that is length times width. The length of this rectangle, okay, is it 6 or is it 10? Well, we can see, no, it's 6, but that gives us useful information, doesn't it? And I'm going to jot it down right now. This section is 6. 10 reflects the whole length of it. So that means this part of it must be 4. I'm going to need that information later. And I noticed it right now as I was looking at the rectangle. So I'm going to go ahead and just write this down so that later I will have that because I think I'm going to need that. Okay, length is 6, width is 4. And that equals 24 yards squared, but I'm not going to write that yet. Now for this B shape, this one is the area of a triangle. That is base times height divided by 2. The base, we just figured out, has to be 4. Now, what about the height? That's not measured either. I know my spider's sitting right here, so that's the dimension I want. But I can see, oh look, this is 4. It's got to be 4 because it's the same as that. So my triangle has a base of 4 and a height of 4. Divide it by 2. I'll cancel, and that becomes 8. And now I'm ready to add them together for 32 yards squared. Fun times, right? Okay, if you need a break, now is a good time to take a break because we still have 2 more sections. We're probably about halfway done, maybe a little more than half, but we still have a ways to go. So pause me now if you need a break. Come back soon. All right, we are ready for the next section, which is areas of circles. When we measure the area of a circle, there's one piece of information we need. We need to know the distance from the center. I gave spoilers. From the center to the edge, that's called the radius. Sometimes I use an uppercase for R, sometimes I use a lowercase for R. That doesn't matter. R equals the radius. When we are measuring the areas of a circle, we're also going to use that crazy pi thing, right? And that's equal to 3.14, and on and on and on it goes. You know, there's many, 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 many digits to pi. We haven't found the end of them. It's a decimal that repeats infinitely. There's no pattern. It just goes on and on and on. Okay, so we need both of these numbers to calculate the area. Remember that pi is this special number that does things for a circle. The ancients discovered it, and it works to this day for our formula. The area of a circle equals pi r squared. Students get confused between the formula for a circumference and the formula for an area. Area is a measure of 2 dimension, right? That's why it has the squared in it. That's how I remember. Circumference has a 2, but it's not an exponent. So when we see the 2 as an exponent, we know that that is the area formula. All right? Let's try a few examples here. Make sure that formula is on your formula page too. 8.6. The radius of a circle is 3 centimeters. I write a little note to myself. Find the area. Now, what's fun about these problems is we really don't even need a picture. All we need is our formula, which is right there, and we know that the area of a circle equals pi r squared. I'm writing it again. I don't need to. And in this case, it's 3.14 times our radius, which is 3. Oh, 3 squared, right? We have to square the radius. All right, that is 3.14 times 9, right? So I'm going to do a little side calculation down here. 3 squared is 9, and then I'm multiplying that by the 3.14. 9 times 4 is 36. 27 plus 1 is 28. I need to put the decimal back in. I have 2 digits behind the decimal in my factors, so my product needs to have the same pattern. So my answer is 28.26 centimeters squared. Cool, right? That's right. Okay. Example 8.7 is this one inside out. The area of a circle is 25 square meters. Find the radius. Okay, well, it's our same formula, but this time we have different information. Last time we had the radius and we were supposed to find the area. This time we're told the area and we have to find the radius. So we plug in what we know, and I'm saying 25 equals pi r squared, right? pi is equal to 3.14 times the radius squared. This is still a mystery. We don't know what that is. But we can see there's our variable. So if we divide both sides by 3.14, that will cancel, and we'll have, I'm just going to bring this over to the other side, r squared equals 25 divided by 3.14. Okay? Now, I don't like this problem because that is a pretty complicated answer, and that's the square, so we're going to have to take the square root of both sides. You can't do that with paper and pencil. You need a calculator to finish this problem, and I don't like that really. So I would be happy with this as an answer. If we were taking a test, I probably wouldn't put a problem like this on the test because it's too confusing. But if you did grab a calculator and solved it, you'd get that the radius equals 2.82 meters, and I would want the unit on this too. That it isn't just to the denominator, I just squeezed it into the corner. So you need the unit on it. But that's what I don't like about this problem, is that we have to divide, which we could divide, that's not the end of the world, but then finding the square root of it, we need a calculator to do that. So, boo! .8. Here come the heavy-duty problems that are generated from this type. Find the area of this figure. Lines that look parallel are parallel. Dimensions are in inches. Ready? There's what John gives us. So now we have to take this into our own hands and figure out what we've got here. Well, I can tell here, there's a triangle. And now that we've been reminded of how we're going to get information about it, I can start to look. Okay, here's a semicircle. 5 is this length. So 7 includes that 5, and then that means this much must be 2, right? I know I'm going to need this dimension. The radius is 2, so that means the radius as measured here is 2. The radius as measured there is 2. So that total side is 4, and this total side is 4. Make sense? The radius gives us half that distance, so we double the radius to get the full length of the semicircle. Okay, now we've got lots of good stuff. So I'm going to start on the left and work across. The area of the triangle is what we'll do first. It's base times height divided by 2. The base of this triangle is 2. The height of this triangle is 4. I did all that work ahead of time, so it's all easy for me. 2 in the formula, that cancels. That means the area of the triangle is 4 inches squared. I won't put the unit on it yet. All right, next up we have our rectangle. The formula for the area of a rectangle is the length times the width. I want to look here and I see the 7, but then I remember, no, that's not right. It's the 5 that I want. 4 this way, and that means the area of the rectangle is 20 units squared. All right, now the area of the half circle, and I remember to draw that in, and that reminds me, oh yeah, I have to take the formula for the area and I have to divide it in 2. So it's going to be pi r squared, that's the area of a circle, divided by 2. When we find the circumference of a half circle, it's pi 2r, and then we divide it by 2, and we find we get this nice little canceling thing. that isn't how it works for the area, because we're not multiplying by 2, we're squaring. There's nothing we can cancel. We have to just go ahead and calculate it and then divide by 2. Okay, so it's going to be 3.14 times the radius squared divided by 2. All right, that's going to require a little bit more work. 2 squared is 4, so I'm going to cross this out and I'm going to write 4. We can cancel the denominator against there, and now we get just a plain 2. And now all we have to do is multiply 3.14 times 2, which is just doubling it, which I can do in my head, right? We double each of those digits, 6.28. As we do more and more of the problems with pi, you'll get better and better at remembering what's 3.14 times 2, what's 3.14 times 3, what's 3.14 times 4. You'll start to memorize those and you don't have to write them out every time. So that's the good news. All right, now we're ready to add. I put decimals in because that's how we add decimal numbers, is line up the decimals. 28, 30.28. That's the right answer. Inches squared. Okay, now you can see how this way of organizing your work can really come in handy. Okay, last section. Are you still with me? Areas of parallelograms and trapezoids. Are you rolling your eyes? I am. These guys are just troublemakers, but the good news is they're not going to make any trouble for us today. Remember that a parallelogram has 2 pairs of parallel sides. All right, a trapezoid has 1 pair. Okay, and I'll show you how we can show that. This little line means that they're parallel. 2 of those shows that the other side are parallel, not to the first ones, but to themselves, right? With a trapezoid, we only have 1 pair of parallel sides. Okay, so they look different, but the way we find the area of them is exactly the same. And it's a fun little hack. So we don't have a new formula. There is a formula that you can use, but I don't like it. What we're going to do instead, and we have 2 more examples, and then we're done with this lesson. Example 10.9, 8 point. Sorry, I'm making things up. Find the area of this parallelogram. John draws us a nice picture. Dimensions are in centimeters. Gives us all of this information. Then he gives us this information. Okay, and we think, he's giving us the lengths of the sides, but he's giving us this too. All right, we'll keep that all in mind. I'm gonna use that color. This is the strategy. We're gonna divide this into two triangles, and we're going to call them A and B like we did before. All right? We'll calculate triangle A, because this is a triangle, isn't it? And we know that the formula for a triangle is base times height divided by 2. And now we have to kind of orient ourselves. Let's take this corner and kind of flip it up and reimagine the triangle like this. Okay, that helps us orient it so we can see it. The base is 8, and the height is not 5. 5 is the length of that side. We need this, right? And that's what this is. So the height is 4. That's kind of weird, isn't it? It's easier to see when we look at triangle B, which we'll use the same formula. Here we can see it a little more clearly. The base is 8, and the height is not 5. The spider's sitting here. The height is 4. And we know that's 16 again, so the total is 32 centimeters squared. Okay, so we don't need a new formula to find the area of a parallelogram. All we need to do is just divide it into two triangles and then use our old familiar formulas. So you have to kind of work to visualize this top triangle. Like I said, it helps to kind of visually peel up that corner and flip it up so that it's like this. But with a parallelogram, the two triangles will be exactly the same as we found out here. So that takes some of the mystery out of it. Let's look at example 810. It's our last one. Find the area of this trapezoid. Dimensions are in meters. And again, we're given this kind of a notation, and we think, okay, that's interesting. We'll hang on to that. Same thing with a trapezoid. We're going to divide it. Now, last time I went from this corner to that corner. You can do it that way, or you can do it this way. It'll work either way. Okay, that one I didn't draw a straight line, but it's okay. All right, so you can't mess that up. You can go in either direction. So triangle A, we know the formula is base times height divided by 2. We can see the base of this is 15. The height, oh, it's not 5. No, it's not. The height will be here, right? Because that's where our little spidey sits, right? Our triangle is cut, but that's the very top. So the height is the same as this, it's 4. So the area of triangle A, which is all of that, is 30, what's our unit? Meters squared. All right, the area of the second triangle, right? Sometimes I like to circle these. So I circle things when I feel like my brain there's too many details floating around and I need to help myself focus in. That's why I circle things. B, now B we have to do the flippy up thing, right? We have to imagine peeling up that corner and flipping it up so it's like this. Right? Kind of. I didn't draw that perfectly. The base of that is 9. The height of that, again, it's not the 5. It's that dimension, and we can say, oh, that's the 4 again. Divide it by 2. Cancel. 18 for the second part. And then again, we add them up. Put a unit on it. square it, and there's our answer. Remember that with trapezoids, which are the funky shape, the two triangles will not be the same. With a parallelogram, which is a more consistent shape, the two triangles will be the same. And it doesn't matter which way you divide them. We could divide it this way and it would work just the same. So don't worry about that. Just divide it whichever way your brain sees to divide it. Parallelograms, the two triangles will be the same. Trapezoids, the two triangles will be different, but the process for finding them is exactly the same. All right, that brings us to the end, finally, of lesson 8. Big review of area. Remember to do all the practice problems and the odd-numbered problem set problems. That will give you a lovely variety. And I will talk to you in the video chats this weekend. If you are a student who found me on YouTube and is just enjoying this lovely adventure through algebra, feel free to reach out to me if you have questions. I hope you're using the solutions manual to help you work out the problem set problems, but if you ever get stuck, feel free to email me or, find me on, you can find me on Facebook, you can find me on Instagram. Reach out to me and ask me questions if you have them. I'm happy to help you. And I love algebra, so, there's that. All right, goodbye.